So, for those who don't know me, hi, I'm Matt. I work at Sainsbury's Tech now. We're not currently using Perl, but working on getting them to use Raku. I'm not opposed to it, so you never know. Watch this space. A few months ago, I made an attempt at replacing myself with an AI. I mean, this is the future, right? AI is going to take all our jobs, so maybe I'll get ahead of the curve. So my job is I write code occasionally, and I also talk to people about writing code. So I figure I've got to be able to automate some of these things. So my plan is maybe I'll automate my job, set the script running, do my job for me, and then go retire to some island, Hawaii or somewhere. I mean, maybe not at the moment, hurricane season, I think. So, enter neural networks. This is the latest trend, kind of the trend. A lot of the text, so image recognition you see under the hood, it's this, but much more complex. So the way it works, your input would be known as, it'd be a tensor, which is an n-dimensional array, basically. So anything that's representable as an n-dimensional array of numbers, you can feed in. So in the case of an image, that would be the RGB values. With video, you can have a series of RGB values. You can encode text into numbers, so you can tokenize it. Or basically anything that's sequential. Musical notation is something that would be interesting to try. It has been tried, but not with a neural network, with some success. What then happens is this will then map to your hidden layer, which is another series of neurons. So the hidden layer, so these blue things, these neurons, just like biological neurons, are actually quite dumb. All they do is a mathematical operation. So tan X is a fairly popular one. The ones I'll be using here are a little bit more complex. They have their own state. I'm not going to go into quite the mathematics behind it because, I'll be honest with you, I don't understand a lot of it. And then that would then map to an output layer. So, as with biological neurons, the important part is not the neurons themselves, but the mappings between them. So this mess of arrows is actually another tensor, which is a bunch of numbers which change. So at the start you initialize it, they're all completely random, and you feed it some training data. So given an input of a picture of a cat, you run it through and it will come up with an output, say identifying what the picture is, and your first attempt is going to be random, so it says, I don't know, it's a picture of a rabbit. But then you can correct it and say, no, this is not a picture of a rabbit, this is a picture of a cat. And then you run it back through the arrows, and using some incredibly complex math and tensor calculus, you can actually make adjustments. So the next time you run it through, it's ever so slightly more likely to tell you it's a cat. So how does this work in practice? Well, first off, you acquire a lot of data. If you're Facebook, Google, GCHQ, or someone, then you're probably sitting on a lot of it. If not, then you've got to acquire this from somewhere. This may or may not be easy, depending on what kind of data you like. And this data might not be entirely reliable. If you train it on bad data, you'll get a bad result. There's been some great examples of networks trained on biased data that have then reflected those biases. So you then train it on the data. Like I said, lots of tensor calculus. There is a paper out there explaining how it works, and it absolutely makes my brain melt. This is the hard part. It requires a lot of computational power, such that Google, Amazon, Microsoft all have facilities dedicated for this. So if you want to rack up a gigantic Amazon bill very quickly, go do machine learning with them. Seriously. Alternatively, you can do it on a laptop, such as this one. It'll make the fan go nuts, and when I did this, I had to leave it running over a weekend and pray it didn't catch fire. It didn't, thankfully. I did find out that the CPU sensor actually, kind of caps out at about 75 degrees. Past that, it just gives up and say, no, you're an idiot. But once you've got that, you'll have adjusted the mappings between the neurons, and you'll have a trained network. Once you've got that, it's very fast. That better? Cool. So once you've got that, that's very fast. It'll run on a phone, a smartwatch. You might find the voice recognition on your phone, the speech to text. That's actually powered by a neural network under the hood. A lot of automatic translations, same thing. But the point is, you can deploy it anywhere, incredibly fast to run. So, back to automating myself with an AI. What's my plan? I use WhatsApp a lot. I can extract everything I've ever said, feed it to a neural network, train it, and then it'll imitate me. Simple, right? So first, let's extract everything from WhatsApp. I have a rooted phone. This is reasonably trivial once you know where the files are. There's an app called Total Commander that makes this nice and easy. However, it's encrypted because, well, WhatsApp aren't idiots. So you have to decrypt it. There's various tools available for this. I used a JavaScript-based one that runs in a web browser. This is completely secure, absolutely. I've checked the network tab, it's not sending anything anywhere. There are command line-based ones if you want to run things a bit more safely. But again, as far as I can tell, this isn't sending data anywhere. I think, maybe. Your mileage may vary. So after that, it spits out a SQL-like database, which you then start up, and the database structure is a bit of a mess. After a little while of staring at it, I eventually found a key from me, which you can use to dump all the data out. Great. I'm just going with things I've said, because it wouldn't be ethical to use things that people have said to me in private conversations, nor would it be GDPR compliant, and we're all scared of that, aren't we? So that's 19,000 lines dumped, and for purposes of this, that's actually more than enough data. So next, I can pre-process it. This will turn a load of words and characters and emojis and what have you into a bunch of numbers, which is a lot easier for a network to work with. There is probably an entire other tech talk in exactly how this can work. I'll just leave it as we'll pre-process it. And there is a Dockerized version of TorchRNN that I'll link to in the notes. So after that, we've pre-processed it. Time to train it. So these are the default settings, just as the Dockerized TorchRNN comes. So it gives you a value called loss, which is how inaccurate or how accurate it is. The lower the better. First iteration, it scored 5 point something. It's about standard for when I've tried. It then got down to 1.89, and it gave me this. It's not quite English. It looks kind of like Swedish and Welsh mixed. However, it looks like a human language. There's even an English word in there, literally there. It's learned to use punctuation. It's learned what a word looks like. It's got spaces. So, okay, let's play around with the default settings. Let's throw more neurons at it. And it's speaking English. Not only that, it's using emojis. I used that one. It's talking about coffee. It's replicating my autocorrect with duck. I love to talk about ducks. So what next? Fiddle it around a bit. I like this. Yarp. It's imitating me. It's not just learning English, it's learning my particular bastardization of English. And again, it's using emojis and the old school emojis. So let's take a typical machine learning approach to this and throw loads and loads of time and neurons at it. So this is where I left it running over a weekend and it didn't catch fire somehow. And actually, yeah, this sounds like me. It's talking about coffee again. Uses emojis, at the end of a sentence. It is grammatically correct in some places. It has punctuation at the end of the sentence. Yeah. It isn't quite going to replace me yet, though. Some more examples. Yeah, we're not quite there yet. I think my job is safe. However, that's only part of my job, talking to people. There's nothing to say that this has to be used on human language. This works with any kind of sequential data. So what about if I trained it to write Perl code? So when I originally did this, I used my current employer's code base. It came out with some interesting examples. I'm not going to show you them. They actually weren't hideous, or no more hideous than the code base itself. Like I said, it reflects the data you feed it. So we've got debit class, we've got dancer, various Acme modules, Modulicious, OpenAPI client, and I thought it'd be funny to feed it PPR and its 1,500 line regex, just to see what comes out. Truth be told, you can feed it as much as you like. And this is the command I use to just flatten the directory structure, because the preprocessor doesn't like digging into nested directories. And so it came out with this. It isn't quite syntactically correct, but that's definitely Perl code. In some cases, actually, yeah. It has come out with some functions that will compile. It also loves writing documentation, which is better than most human developers I know. Oh yeah, this is where I tried writing my own debit class module, debit class machine learning. There we go. Don't think I'm going to publish it to CPAN, but maybe it comes out something better. And I can generate a method. Fast prime factorization algorithm, anyone? Well, here you go. Don't think it'll do something, I'm sure, but probably isn't fast prime factorization. So I then figured, what does the world need more of? Well, I don't think there's enough JavaScript frameworks. So what if I fed it some JavaScript? We've got the lovely unholy trinity here of React, Vue, and jQuery. Let's train it on that. That right there, that's an atomic. That's in one of those code bases. I'm genuinely at a loss. I don't know how that got in there. It's been used somewhere in the code bases of one of those three. I'm not sure if JavaScript even lets you do that, but here we are. It also, in the comments, is ranting about IE and the hacks that you have to do to get it to work. Looks like JavaScript. So in doing all of this, I wrote some very handy automation scripts, basically because I got kind of lazy and was annoyed trying to remember the same commands. So this is on GitHub. Plug and play. I used it to generate the Perl code and the JavaScript code. Check it out. Stick it in the source data folder. Runs on a Mac and Linux. You could probably get it to run on Windows if you wanted to. It's set up to use just CPU only at the moment. There is a GPU version of TorchRNN. In theory, it'll work, but I haven't tested it. So your mileage may vary. There's a script called run all. It would just take all your data, pre-process it, train on it. It can take quite a while, but it saves checkpoints. And then it will spit out samples. You can also separate, so you can pre-process until you get it right. You can train and pick up from checkpoints. Yeah, it's great. So then I figured, what else can I train it on? So I didn't want to use another code base. I'm sure there's some entertaining examples out there. That's the next step. So somebody has gotten it to work on pre-processing on words rather than characters. So when I was training it based on myself, first you could see it getting more accurate, and then it kind of hit a wall for a while. And that was, I think, where it got the sentence structure right, but didn't get the whole speaking English thing right. But then at one point you can tell it learns English and it suddenly gets much more accurate. If you pre-processed it on words instead of characters, you remove the need to learn English, which means it can focus its time and neurons on speaking accurately. You could write a chatbot with this. Watch this space. I might try and do it. other code bases, other languages, and non-language data. So any sequential data you can use this with. So I'd be interested to try it with musical notation or something. I don't know if you fed it all of Mozart's back catalogue or something, maybe fed it Skrillex or something as well, see what comes out. But then I figured, what else can I point at? So what if I could find some well-respected source of wisdom on the internet somewhere and train it off of that? Maybe the complete works of Shakespeare, maybe Wikipedia, Encyclopedia Dramatica. But then I thought, nah, that's boring. So I trained it on Donald Trump's Twitter account. So I set it training for an hour or so, and it came out with this. I think he's speaking Japanese. It's a bit different. I think the model file got corrupted there a little bit. So I redid it, and it works this time. Expect a dummers tonight, and you should be back to pens, thanks. I mean, it kind of sounds like him. Yeah, how's the golf course going? Golf course due to help, I agree, watch meeting year's work. Yeah, that actually sounds like him talking about his golf course. We've got political witch hunt, we've got Russia, we've got Amazon, we've got the wall, we've got presumably the 15th Amendment. Not a lawyer, don't know what that is. This sounds like Trump. But the question that everyone's dying to know the answer to, what does Trump think of Perl? Well, Pearly Bill. Thank you, everyone. Are there any questions?
Can you be, when you're doing training on computer language, can you tell it what it output compiles and use that to train it to only output stuff that will run?
Not with what's out of the box, but if you were to modify the code, that should be possible, yeah. It might not be necessary. There's probably a bit of nuance to doing it, because you can't, if you started training it immediately on it must produce compilable code, then it will probably take a while to get there. So you want to give it a bit of creative freedom before you start enforcing it. But later on, actually, yes, you could do that. Yeah, torch RNN, which is what I've used here, probably isn't the best way to do it. There's better tools out there now. So there's TensorFlow, there's one called Keras, which is built on top, which you'd probably be better off using. Uses the GPU natively. So actually, yeah, you could very well do that. One thing I would like to try is just piping some of this to a compiler. Just running whatever comes out, see what happens.
That's not actually a question. The emoji you got with the JavaScript one is the reaction of it.
Ah!
As a bigger, I recognize that.
That's where it came from then. Huh. Mystery solved. Any more questions? Cool. So, torch RNN kit is there. Put whatever you like in it. I've seen some great results of training it on various languages and code bases. Again, it reflects what data you feed it. Thank you, everyone.